Hey guys, I hope you're having an awesome day. In this video, you'll find a lesson on how to multiply and divide decimals. If you're a bit shaky on using the standard algorithm for multiplying or dividing, please check out one of my previous lessons on those topics on my Pre-Algebra playlist. The objective of this lesson is to give you the tools and understanding of how to fluently multiply and divide decimals and apply those skills to various application problems. Let's get into it. In order to multiply decimals easily, it's important that you already understand how to use the standard algorithm for multiplication. I've summarized the process for multiplying decimals into 5 easy steps here. In step 1, we're going to count the total decimal places that we have in total. When I say that, I'm talking about the number of numbers to the right of the decimal place. In 42 and 75 hundredths, there are 2 numbers to the right of the decimal place. In 7 and 3 tenths, we have 1 number to the right of the decimal place. When looking at our factors, we have 3 total decimal places, or rather 3 numbers to the right of the decimal place. Step 2, we're going to ignore the decimal points. Step 3, we're going to set up the standard algorithm. Notice how I don't line up the decimal points. While it's important to line them up when adding and subtracting decimals, it's not necessary when you're multiplying. Since we're going to ignore the decimal points, just line up the numbers based on their place values. Step 4, we're going to multiply using the standard algorithm. And finally, in step 5, we're going to insert the decimal into the product to match the total places from step 1. Since we sort of ignored 3 decimal places in our factors, we need to bring back 3 decimal places in our product. The final product here would be 312 and 75 thousandths. Now, when I said we were kind of ignoring the decimal places, we aren't really doing that. When we pretended that 42.75 didn't have a decimal, we really were technically multiplying it by 100. When we do that, we slide the decimal over 2 times to the right because it's 100 times bigger. And when we were ignoring the decimal in 7.3, we were really multiplying it by 10 to slide the decimal over 1 time. If we multiplied one of the factors by 100 and the other one by 10, we really are multiplying the product by 1,000. Hopefully it makes sense why we're going to divide our product by 1,000 to get a more reasonable answer. While this is what's really happening behind the scenes, feel free to imagine that you're just ignoring the decimal places and putting them back in at the end. Just like multiplying decimals, dividing decimals depends on the standard algorithm as well. First, we're going to check to see if the divisor is a whole number, meaning there's no decimal. Just like multiplying decimals, dividing decimals depends on your ability to use the standard algorithm. If you can follow these 5 steps in dividing decimals, you're going to do great with it. Step 1, you're going to check to see if your divisor is a whole number, meaning it doesn't have a decimal. When you look at this example on the left, notice how the divisor is 5. Since that's a whole number, you can go straight into using long division. However, when you look at the example to the right, our divisor is 2 and 3 tenths, which is not a whole number. This one's going to require some more work. Step 2, if it's a whole number, great, but if not, multiply the divisor by 10 until it becomes a whole number. Since 2 and 3 tenths only has 1 decimal place, multiplying it by 10 will do the trick. If it had 2 decimal places, you would multiply it by 100. Notice here how we multiply 2 and 3 tenths by 10 to get 23 as our new divisor. To be fair, if we're going to multiply the divisor by 10, we should also multiply the dividend by 10. Notice how 48 and 75 hundredths becomes 487 and 5 tenths. The quotient of this circled problem will be the same quotient as the original problem. In step 3, you repeat what you did with the divisor to the dividend. Since we're multiplying 2 and 3 tenths by 10, we should multiply 48 and 75 hundredths by 10. In step 4, we'll divide using the standard algorithm. Now that our divisor is 23, which is a whole number, we can use the standard algorithm. Finally, in step 5, the decimal location in the dividend will determine the decimal location in the quotient. Notice how the decimal place in the quotient is just going to copy the decimal place of the dividend. Now, if you're wondering why you can multiply the dividend and divisor both by 10 and get the same answer as the original problem, let me try to convince you here. Hopefully you can agree with me that 6 divided by 3 is 2. What's interesting is, if you multiply 6 by 10 and 3 by 10, you get 60 and 30. But if you divide these 2 values, you still get 2. If you take the same 6 divided by 3, but you multiply both of those values by 100 and make them 600 divided by 300, we still get 2. If you take that same 6 divided by 3 and you multiply them both by 100 to get 600 divided by 300, you still get 2. Last but not least, if you multiply them both by 1,000, you'll get 6,000 divided by 3,000, and surprise, surprise, it's still 2. As long as you multiply the dividend and divisor by the same value, you're still going to get the same answer no matter what. The divisor is always going to be in charge and be the boss. If the divisor has 1 decimal place, we're going to multiply both divisor and the dividend by 10. If the divisor has 2 decimal places, both of them are going to be multiplied by 100. This will be the case in all the division problems you're doing with decimals. Now that we've talked about the process, let's try to put it into action. After all, one of the best ways of learning is by doing. I'll walk you through a few different types of problems and give you the chance to practice and check your answers as well. At the end of the lesson, I'll do a couple application problems as well to make sure you understand what you're doing. In example 1, each of these problems is going to have 1 decimal and 1 whole number. I'd like you to take out a piece of paper and something to write with and try these with me. Remember, we're going to start off by ignoring any decimals we see and just treat the numbers as whole numbers. We're going to look at this 7.8 as 78. Since both of these factors have 2 digits, it doesn't matter which one goes on top. We will, however, note that there is 1 decimal place. This is where we need to use the standard algorithm. We'll start off by multiplying 8 by 5 to get 40. I'll put the 0 and carry the 4. 8 by 3 is going to be 24, plus 4 is going to be 28. We're done with these values, so we're going to move on to the 7, which is a 70. 7 by 5 is going to be 35, we'll carry the 3. 7 by 3 is 21, plus 3 is going to be 24. We're going to take these partial products and find the sum. We're going to get a 0 here, we're going to get 13, carry the 1, this is a 7, and this is a 2. Since we had 1 decimal place in one of the factors, we should have 1 decimal place in our product. The final product here is going to be 273. Let's do a quick estimate to see how reasonable our product is. 35 is close to 40, and 7 and 8/10 is pretty close to 8. If we find the product of 8 and 4, that's going to be 32 with an extra 0. Since we rounded both values up, 320 is going to be a little bit higher than 273. This is reasonable. If you forgot to put the decimal back into the product, you're going to see that you would not have had a reasonable answer. 2,730 would have just been way too big. Let's try another one here. We're going to write 485 on top, and we're going to write 27 hundredths on bottom. If you ever have a decimal with a whole number, you don't need to write this 0. Again, we're writing the 27 hundredths on bottom since it has less digits. We're going to start off by doing the standard algorithm and see what our product is. Hopefully you notice that 27 hundredths has 2 decimal places and 485 has none. Then you're going to go ahead and use the standard algorithm. 7 by 5 is going to be 35, carry the 3. 7 by 8 is going to be 56, plus 3 is 59, carry the 5. 7 by 4 is 28, plus 5 is going to be 33. We're done with the 7 and the 3 and the 5. We'll move on to the 2. 2 by 5 is going to be 10. We're going to carry the 1. 2 by 8 is 16 plus 1 is 17. Carry the 1. And 2 by 4 is 8 plus 1 is 9. Let's find the sum of these 2 partial products. And we'll get a 5 here, a 9 here, a 10 here, carry the 1, and a 13. Since our factors contain 2 decimal places, our product needs to move 2 decimal places as well. Here we'll have a final product of 130 and 95 hundredths. Now if you take a quarter of 400, that's actually going to be 100. This is going to be on the low side because we rounded 485 down. While 485 is definitely closer to 500, finding a quarter of 500 is a little bit more difficult to do. If you put your decimal anywhere else in this product, you would have gotten a value much different than 100. Now that we've tried to couple together, I'd like you to pause the video and try this one on your own. When you're ready, unpause it to check to see how you did. In example C, your product should have been 198. Let's just try one more with 1 whole number and 1 decimal. Pause the video and give this a try. In example D, you should have gotten 3,308 and 526 thousandths. In example 2, both factors are going to have decimal places. Let's try one together. As we begin, we're going to ignore the decimal places and notice that both factors have 2 digits. Since they both have 2, it doesn't matter which one goes on top. We take note that both of these factors have 1 decimal place. Then we'll just start using the standard algorithm. 3 by 9 is going to be 27, carry the 2. 3 by 2 is 6, plus 2 is 8. We're done with the 3 and the 2, and move on to the 7. 7 by 9 is 63, carry the 6. 7 by 2 is 14, plus 6 is going to be 20. Find the sum of these partial products to get 7, 11, carry the 1, 1, 2. Since our factor had 2 decimal places, our product has to as well. Our product here is going to be 21 and 17 hundredths. To see if this is reasonable, we can round 2 and 9/10 to 3. We can round 7 and 3/10 to 7. Product of 3 and 7 is 21, which is pretty darn close to 21 and 17 hundredths. Now it's your turn. Pause the video and give this one a try. Unpause it when you're ready to see the answer. The product should be 30 and 96 thousandths. And here's another. Pause the video and give this one a try. Here, the product should be 17 and 177 thousandths. And here's one final one. Pause the video and give it a try. Unpause it to check your answer. Here, the product should be 24 and 19 hundredths. In this third example, each problem will be a division problem with a whole divisor. Let's try some together. We start out by writing the dividend inside the division house and place the divisor 5 outside on the left side. Since 5 is a whole number, we can begin right away. The decimal that's in the dividend is going to be the same decimal place that's going to be in our quotient. Now for the standard algorithm. 5 fits into 3 0 times, but 5 fits into 30 6 times. 6 times 5 is going to be 30 with a remainder of 0. Here we're going to bring down the 6 to team up with the 0 and repeat the process. 5 goes into 6 one time. 1 times 5 is 5. We're going to subtract. We get a remainder of 1. We're going to bring down the 8 to repeat the process here. Now we have 18. 5 fits into 18 3 times. Notice how this 3 is to the right of the decimal place. 5 by 3 is 15. We have a remainder of 3. Since we still have a remainder, we're going to write a 0 inside the dividend and bring it down to join the 3. We're going to repeat this process one more time here. 5 fits into 30 6 times. 5 by 6 is 30. And we actually have no remainder now. The final quotient here is going to be 61 and 36 hundredths. As a quick estimate, I'm going to take 306 and 8 tenths and round that to 300. Since 5 is a single digit, I'll just keep it the same as 5. If we do 300 divided by 5, that's going to be 60. Our answer seems pretty reasonable here. Let's try one more together. We'll start off by multiplying 36 times 5 to see where we're at, and that's going to be 180. Let's even go a little higher here. If we know 36 times 5 is 180, then if you have another 36 on top of that, that's going to be 216. However, if we go a little higher than that, we're going to go over 230. Let's put a 6 up here. 6 times 36 is going to be 216, and we're going to subtract to see what our remainder is. 230 minus 216 is 14, and we'll bring down this 2 to team up with the 14 to repeat this process. Since 36 times 5 was too big, we should try something like 36 times 4. 36 times 4 is going to be 144. Since it's a little bit too big, we should try something like 36 times 3. 36 times 3 is going to be 108. We'll put a 3 up here in our quotient and multiply 3 times 36 to get 108. When we subtract here, our remainder is 34. We'll bring down the 2 to repeat this one last time. Now we know 36 times 10 must be 360, so it has to be 36 times 9. 36 times 9 is going to be 324. This is going to work. Put a 9 up here in our quotient. 9 times 36 is going to be 324, and we'll subtract to get a remainder of 18. Remember, we can add a 0 in our dividend and bring it straight down to team up with the 18 to make 180 and repeat this process again. Since we already knew 36 times 5 is 180, we can put that in our quotient. 3 times 36 is exactly 180. We subtract to get our final remainder of 0. Our quotient here is 6 and 395 thousandths. Now it's your turn. You know the drill. Pause it and unpause it when you're ready to go. Quotient here should be 89 and 43 hundredths. And here's just one more where the divisor is a whole number. Pause and unpause when you're ready. The quotient here will be 5 and 795 thousandths. In example 4, we're going to try dividing decimals where both the dividend and the divisor both have decimals. After we do one together, you're going to do 3 on your own to practice. In this example, notice how 7.49, the divisor, is not a whole number. Right away, we notice that the divisor, 7.49, needs to multiply by 100 to become whole. If we're going to multiply that one by 100, we're also going to multiply 5.992 by 100 as well. Now that the divisor is a whole number, we can go ahead with using the standard algorithm. The decimal in our dividend is going to come up here into our quotient. 749 doesn't fit into 5, and it doesn't fit into 59, and it doesn't fit into 599. At this point, we know the answer is going to be less than 1. And that makes sense because 7.49 can't fit inside of 5.992 one whole time. In my head, I'm going to round 749 to 700 and think about multiples of 7. 7 times 8 is 56, which is pretty close to 59. In that case, I'm going to go with 8 here and see how close I get. 9 times 8 is 72, carry the 7, that's 32, plus 7 is 39, carry the 3, it's 56, plus 3 is going to be 59. 8 times 749 is going to be 5992. We subtract to see the remainder, and there's nothing. The quotient here is just going to be 8 tenths. If I were to estimate here, I would round 5.992 roughly to 6, and I would round 7.49. I know it's closer to 7, but I personally would round it closer to 8, because I know if we're going to do 6 divided by 8, that just simplifies to 3/4, and that one mentally is 0.75 or 3/4, which is really close to 0.8, so I think this is a pretty good estimate. Now it's your turn. I gave you a hint to start off the problem. Pause the video and give it a try, and check out when you're done. This one's pretty interesting because even though you start out with two values that are decimals, the quotient here is actually a whole number. If you're wondering why the quotient of 1,820 is larger than the initial dividend, it's because we're dividing by something smaller than 1. Whenever you're dividing something by smaller than 1, the quotient actually gets larger. And let's try another here. Pause the video and give it a go. Unpause it when you're ready to check. Here, you should get a quotient of 21 and 4/10. And here's one last one of these. Pause the video and give it a try. Your quotient here should be 98 and 1/10. That brings us to our fifth example, where we're going to try some word problems to apply what we just practiced. In example A here, 6 friends go out to eat. Apparently the food costs a total of $56. They want to tip 20% and tax is 7%. If they want to know the total cost of food, tax, and tip, they should multiply the food cost by 1.27. The 1 represents 100% of the food, and the 0.27 represents the tax and tip percentages combined. If split evenly, determine how much each person should pay. Now, if you don't really know how to calculate tax and tip yet, don't worry. In this problem, you're just going to multiply the cost of food by 1.27 to get the total cost. We do know the cost of the food was $56. For the sake of simplicity, I suggested just multiplying by 1.27, or 127%. The total cost is going to be divided among 6 friends, and that's going to equal the cost per person. I'm going to start off by multiplying 1.27 times 56. Notice how the zeros don't matter from the $56, so we can leave them off. 7 times 6 is 42, we're going to carry the 4. 6 by 2 is 12, plus 4 is going to be 16, carry the 1. 6 by 1 is 6, plus 1 is going to be 7. Done with the 6, 4, and 1, and put a placeholder. 5 by 7 is 35, carry the 3. 5 by 2 is 10, plus 3 is 13, carry the 1. And 5 by 1 is 5, plus 1 is 6. Add these partial products together. We're going to get 2, 1, 1, 7. Since we have 2 decimal places in 1.27, we should have 2 decimal places in our product. The 71.12 represents the total cost including tax and tip. Now that we know the total cost of the food was $71.12, we should divide it among 6 people evenly. Since 6 is a whole number, we can go straight into just doing long division. 6 goes into 7 one time. 1 times 6 is 6, and we subtract here to get a remainder of 1. We bring down this 1 here to combine with the 1 to make 11. Repeat the process. 6 goes into 11 just 1 time. 1 times 6 is 6. We subtract to get a remainder here of 5. We're going to bring down this next 1 to combine with the 5 down here and repeat the process. 6 goes into 51 8 times. Put an 8 up here in our quotient. 8 times 6 is going to be 48. Write that down here and subtract to get a remainder here of 3. Here we're going to bring this 2 down to join with 3 to make 32. 6 fits into 32 5 times because 5 times 6 is 30. And write that down here and subtract to get a remainder here of 2. Now since we're talking about money, we need 2 decimal places because we have pennies. If that's the case, we're going to have to actually go to the 3rd decimal place to know if we should round up to 86 cents or keep it at 85 cents. Remember, we can add a 0 inside our dividend, and we'll bring it down to join with the 2 to see what we have left. 6 goes into 20 is going to go in 3 times. 3 times 6 is 18, with the remainder here of 2. Remember, the money we use only has 2 decimal places. The only thing that's important here is the 85. If this 3 was a 5 or higher, it would actually round up to 86 cents. Since it's 4 or lower, we keep it as 85 cents. It turns out the total cost per person would be about $11.85. Now here's the last problem you're going to try on your own. Read the question carefully and make a plan for it. If you're not sure how to set up the problem, feel free to skip back to the last example to see how it was set up. Pause the video one last time to give this one a try. When you're ready, check it over. At this point, it is my hope that you now have a much better understanding of how to multiply and divide decimals, and you can apply these concepts to any problem that you need to. Keep up the good work, and I'll see you in the next one.